Beyond the horizon lies a passage barely wide enough for the vessels that need it. The ships waiting outside are among the largest machines ever built. A single loaded oil tanker can stretch longer than 3 football fields laid end to end. And yet, the water they depend on is one of the narrowest and most contested shipping corridors on Earth. So a question hangs over the anchored fleet, over the markets, and over refineries thousands of miles away. Why can the global energy system not simply go around the Strait of Hormuz? The answer is not what most maps suggest. The Strait of Hormuz connects the Persian Gulf with the Gulf of Oman and the Arabian Sea. It sits between Iran to the north and Oman to the south. This is the only sea route out of the Gulf. Every barrel of oil that leaves the region by ship must pass through it. At its narrowest, the strait spans only about 21 nautical miles. But that figure is misleading. The ships are not free to use all of that water. Because the passage is so tight and so crowded, the International Maritime Organization, the United Nations body that governs global shipping, established something called a traffic separation scheme here decades ago. Picture a highway drawn onto the sea. One lane carries ships inbound toward the Gulf. Another carries ships outbound toward the open ocean. Each lane is only about 2 nautical miles wide, with a buffer zone of similar width running between them. So the working corridor is far thinner than the strait itself. Giant tankers move through it almost in single file, in fixed directions, with very little room to swerve. Islands, shoals, and shallow coastal waters press in on either side. The lanes exist because the alternative, hundreds of enormous vessels crossing freely, would be chaos. The bottleneck, then, is not a thin blue line on a chart. It is a carefully organized transportation system that keeps some of the heaviest objects on the planet moving in predictable order. Consider what actually travels through those lanes. A very large crude carrier, the workhorse of the oil trade, runs roughly 330 meters long. Fully loaded, it sits about 20 meters deep in the water and carries close to 2 million barrels of oil. That single cargo can be worth a substantial share of a nation's daily fuel supply. A ship like that does not behave like a car approaching a roadblock. It cannot stop on command. From full speed, a laden tanker may need several kilometers and many minutes to come to rest. It cannot turn sharply. Its officers watch the world through long sightlines and slow, deliberate responses. These vessels rarely tie up at an ordinary dock. They load at specialized offshore terminals inside the Gulf, where pipelines pump millions of barrels aboard over many hours. Then they turn, line up, and thread back out through the same narrow lanes they entered by. The main channels run deep, roughly 60 to 100 meters, enough for even the largest ships, but the width remains unforgiving. Oil is only part of the cargo. The Strait of Hormuz is also the gateway for close to a fifth of the world's liquefied natural gas. Natural gas chilled until it turns to liquid and shrinks hundreds of times in volume. Qatar, one of the largest exporters on Earth, sends almost all of its gas out this way. Liquefied natural gas cannot travel on just any ship. It requires specially insulated carriers that hold the cargo colder than almost anywhere in nature. It requires dedicated loading plants and dedicated receiving terminals built to turn the liquid back into gas. You cannot pour it into a spare oil tanker or unload it at a random port. That is the deeper truth beneath the headlines. The ships, the terminals, the refineries, the contracts, and the pipelines are not separate parts. They function as a single integrated machine, and that machine was built around this one strait. Which returns us to the question, if the passage is so vulnerable, why not simply use pipelines? Some do exist. Saudi Arabia operates a major pipeline that carries crude across the country from its eastern fields to the Red Sea coast, bypassing the Gulf entirely. The United Arab Emirates runs another line, roughly 400 kilometers long, from its inland oil fields to the port of Fujairah, which sits on the Gulf of Oman just outside the strait. These routes are real, and they matter, but they solve only part of the problem. The difficulty is spare capacity. A pipeline's headline capacity is not the same as the room actually available to move extra barrels. Weighing the two together, energy agencies estimate that only around 3.5 to 5.5 million barrels a day could realistically be diverted around the strait. Now compare that to normal flow. In recent years, roughly 20 million barrels of oil and petroleum products moved through the Strait of Hormuz every single day. The bypass pipelines running hard could carry only a fraction of that total. The rest has nowhere else to go. And pipelines are not simple taps you open wider. They depend on pumping stations, storage tanks, pressure control, maintenance, and terminals matched to specific grades of crude. Push them past their limits, and they cannot hold it for long. For liquefied natural gas, the picture is starker still. There is no bypass pipeline that delivers Qatar's gas to the global market. The molecules leave as chilled liquid aboard specialized ships, or they do not leave at all. So the world cannot easily go around. But a second surprise is waiting. A strait does not need to be physically sealed to stop working. No one has to sink a vessel across the entire passage. The corridor can be closed by risk alone. Naval mines are one reason. A mine is cheap to place and slow to find. Once ships suspect that mines are in the water, traffic can freeze long before every device is located because clearing them is painstaking work carried out by specialized mine-hunting vessels moving slowly through dangerous water. Then there are drones, missiles, and the boarding and seizure of commercial ships. A single damaged tanker can generate an exclusion zone, a fire risk, a salvage operation, and a cascading traffic jam without ever forming a wall across the water. Modern ships also lean on invisible infrastructure. Satellite positioning, radar, and the automatic identification system that lets vessels see one another all depend on clean signals. When that data is jammed or falsified, a tanker with almost no room to maneuver is suddenly navigating half-blind through the world's tightest oil corridor. This is close to what has unfolded since a war between the United States and Iran erupted at the end of February this year. Iran's Revolutionary Guard have declared the strait closed, warned ships away, and, according to maritime authorities, laid mines and attacked or seized commercial vessels. Iran has even redrawn the traffic lanes to route ships through its own coastal waters. The United States rejects the claim that the strait is shut. Its Navy has escorted convoys through, and on one recent day, American officials said more than 8 million barrels of oil crossed with military assistance. The precise status is disputed and shifts week to week. But the trend is not in doubt. On a normal day, close to 90 ships pass through. On recent days, that count has fallen to barely a dozen. Many cross with their transponders off. Insurers have pulled back, some crews have refused, and mainstream shipping companies have suspended runs they once treated as routine. In the first quarter of this year, official figures show flows already dropping by nearly a third. The strait is not sealed shut. It has become something almost as disruptive. It is a place most of the world's ships will no longer willingly enter. From there, the effects ripple outward in a chain. Tankers wait. Storage tanks inside the Gulf fill toward the brim. Loading slows at the terminals, and producers are forced to throttle back their oil and gas fields. Gulf output has already been cut by millions of barrels a day. The pain is not spread evenly. Most of the oil leaving the Strait of Hormuz normally flows to Asia. China, India, Japan, and South Korea are the largest buyers, and their refineries are tuned to particular crude grades, locked into contracts, and reliant on this steady supply. This is not the same as the world running out of oil. It is a transportation bottleneck, a surge in risk, and a scramble for scarce cargo. Prices climb. Some governments release emergency reserves. Others hunt for costlier barrels elsewhere. The countries hit hardest are simply those with the fewest alternatives. And this is the lesson buried inside the crisis. The Strait of Hormuz was never designed as a machine. Nature merely left a gap between two coastlines. But over decades, the world built around that gap. It built larger tankers, faster loading terminals, longer pipelines, and refineries matched to Gulf crude. The very efficiency of that system in calm years is what makes it so fragile in a crisis. The problem was never only that the strait is narrow. The problem is that so much infrastructure quietly assumed the ships would always keep passing through. So the tankers wait at anchor, dark and motionless, off the coast where the Gulf meets the open sea. Humanity has engineered vessels longer than skyscrapers, terminals that pour millions of barrels in a day, pipelines that span entire nations, and navigation systems accurate to a few meters. It has built almost everything, except a replacement for this one narrow passage.